two's complement. Like
Oh, perfect. Okay,
it's like a
good.
separate like file, like a project
Yeah,
itself. Like I did test
nice.
bench and it works.
Okay, cool, cool. So yeah, then you'd have the two's complement. I mean, you could have okay, so like let's say that's your number and you have it in hex. I mean, you could. The simplest thing to do. Let me draw it. It's a little sorry, it's a little messy here, but this could be your switch coming in, and this would be your. Let's just call this n. All right, this would just be n. That's one option. Or you also take n and then go through the two's complement, and then that would be your other thing. So this would be one input, this would be another input. So when the switch is 0, you're just doing the normal number, and if the switch is 1, then you're making it negative, basically.
So kind of like a mux.
Yeah,
You know.
you could do it. Basically would be a mux. Yeah. So you'd have. I know this is a little messy here, but you have your number, and then you either are using the normal number or you're using the two's complement number. And
Okay.
this,
Okay, I see.
yeah. So that's how I do it. And then you'll, I'm assuming, have other, you'll have other stuff then after, of
Yeah.
course.
Yeah.
And then you'll want to go, you do your arithmetic, and then you're going to want to go hex back to BCD. I'm assuming, right?
Yeah.
I think so. Yeah. Yeah.
Yeah, because you'd want to show really any calculator. You're pretty much going to want to show it in human numbers, not in.
Right.
You'd want
I,
something that somebody off the street would be able to work, and they're like, "Why does my calculator say F?"
Right.
I,
so,
Makes sense.
um, so yeah, but yeah, that's how you. That's one way that you could do that. Another way, you could have. This would be a fancier way, but you could have a state machine that would let you do input minus 10. And at the beginning, it would accept either your number or it would accept minus your number. That's a way that you could do it. And you have to think about it that way. You could think about the states in terms of like, what are all the different possibilities? I could get a sign, or I could get, um, digit one and then digit two, or it could be digit one and then digit two, and then you're going to get an operator. So you're probably going to do like 10 plus 10, enter. Is that kind of the idea? And then you'll show the number.
Yeah.
yeah. I guess.
Yeah. So then you would just have to, and these aren't necessarily states yet. I'm just sort of thinking what, like, the possibilities you'd have to cover. You could do like sign and then a number and then an operation and then another sign. I don't know. You have to think about how you want to do it. But there's a lot of different ways to do it. Um, yeah, and you could do it with either a state machine or you could also use you could kind of just do this decoder type thing that we did in Lab 5.
Uh
But
huh.
state machine would be cool too. Um, does that? Yeah. So we answered your question here. Um,
Yeah, that's
what
helpful.
cool. And then um, let's just think through real quick. Did you guys have any other types of questions?
Um, I think that. Oh well, what if? So since we're doing like 8-bit wide operators, like what if the number is like too big to fit on like the little 7 6? Like
Well,
because we're gonna have like the uh like the BCD representations of
yeah.
A and B on like I guess it would take four. And then we'd have four as like the answers, like four that would show the answer.
Well, you would if you have. What are the biggest numbers that you could technically do? Um, 8-bit. If you're only doing 2 digits, the biggest number you're ever going to have is 99.
Yeah.
All
Mm-hmm.
right. And then 99 plus 99, 18. I'm bad at math, but I know it's 198, right? So
Well,
that's the biggest number.
multiplication.
Yeah. What
Oh,
about multiplication and like division?
right. Well,
It would be
90,
4 digits.
yeah, biggest 99 times 99 be 9801. Yeah, I mean, but you got four. You got
Yeah.
I
that.
guess. Yeah,
Yeah,
that makes
even if
sense.
you have the basis, you have four. So,
Yeah.
Yeah, that was our original plan.
Okay.
um, and just let's think about this for one sec. Just to give you some food for thought, if you did a state machine, you could think of your states as, um, you could think of, basically you're going to have digit 1, digit 2, operation, digit 3, digit 4. So here you might have a state here and you're waiting for your first digit. And then in this state, it saves it. And then the next state, you wait for your next digit and it saves it into those two registers. And then you save the code for the operation and you have a register, this would sort of be your operand A, and these would each be 4-bit. So this is just, and then you'd have your operation here, and this is maybe a couple bits that you just set based on what your operation is. Maybe 0 is add, 1 is subtract, 2 is multiply, etc. Right? And you would decode based on, did you get a positive, depending on what key you did. You don't have to do divide. You could do divide. Divide's a little hard, but you could do it. Whatever you want to do. And then you'd have in these states, it's waiting for the next two keys. And this would be two other 4-bit numbers. And then you could either at this state, answer. You could just have it show the answer, or it could show it immediately. You kind of have to play with it and see. But you could have states where it's waiting for the next thing. And then think about it, you're just sort of doing, and maybe you want to have one for enter.
Mm-hmm.
Maybe you want to have one, maybe you want to have delete, makes you go back to here. Right? So then that way, let's say you screw up when you're entering, you just hit delete and it goes back to the beginning. That'd be kind of cool.
Yeah, that would be cool.
So consider a state machine here as a possibility. You can kind of look at the example that I did for the different states for the 2700 detector. That's a real similar type of a thing. Because let me show that real quick. It I think is very similar. It's in principle very similar to what you're doing. So remember we had sequence detector, and I don't have quite enough time to run it on the board, but I'll just look at the top here, and we'll look at sequence detect. And okay, cool. So we had different states here, and depending on what input, it went to the next state. But you could have it, for example, you could potentially have it that if it happens, just always go to the next state, or if it's a, depending on what codes it is, go to the next state. You could have a big if this or this or this or this, go to the next state. Okay, but what I had was, where is it here? I had a debounce, and this basically took my button press, like when I pressed a button on the board, and made it just one little pulse. Just like the keyboard thing does, I think. I think the keyboard thing only gives you just a little pulse, one clock cycle pulse. So same kind of pulse here. And then I took the switches as the input. So for this, you could have, instead of the switches, you could use something like the keyboard. And then instead of D invalid, it would be the pulse from Dr. Lamoka's keyboard module. And then you could hack this up to go through your states, and maybe one state is wait for the first digit, one state's wait for the next digit, one state is wait for the operator, one state is wait for the next digit, one state is wait for the next digit, and then an enter, it goes and does whatever. And you can decode you can use the present state to do different things. You can use, does that kind of make sense?
Yeah.
Yeah.
Sense.
So you could use this as the skeleton for what you do for the calculator. That's one way to do it. That's a better way to do it. It's a cooler way to do it. It's a better grade way to do it. Not just, it's not just for fun. It would be a better project. Yeah. And then this you could do as a backup if you really have trouble with the state machine.
Okay.
This will still work. You could be like, okay, I'm putting in my digits here.
Yeah, it's way less elegant. Yeah, we'd have to flip a switch to choose the digit. Yeah.
Right. This, and I'll tell you what I told some of the other groups. Like, you want this thing, a good project means like a good product. And like, if you just had somebody off the street, random, normal person, non-engineer person, and if you did like 10 plus 7 even, and then you hit enter, and then you show 17 on there, that's perfect. You're thinking, okay, well, if I want to show 7, this is another thing you could do. Again, it's just different degrees of, what you want to do. But you could easily do 10 plus 7, enter, and get an answer versus 10 plus 07, enter, right? Because you could have the states go in a certain way where, let's say you're at this state where you're waiting for this digit, then if you get an enter, you just skip it and go to the end. You know what I mean?
Right.
Mm.
And so you could call these, by the way, wait for digit 1, wait for digit 2, or sample digit 1, sample digit 2, if you want to make it more clear. And you can name these whatever too, by the way. They don't have to be, you could be like, get digit, I was typing on the random keyboard, get digit 1. You can call them whatever you like. And this could be like, get digit 1. And then that's the state where you're like waiting for a keyboard number. And you could then you save it if it's the number that you like. Just, you'd have to maybe play around with it a little bit, but state machine would be pretty cool. So hope that makes sense.
Yeah.
Did you guys have other questions? I know I just kind of went into this whole state machine thing.
No, that was perfect. Go ahead, Delano.
I think that's it. Oh, wait, for the answer, like, let's say it's like a 3-bit thing, or like a 3-digit number, I mean.
Yeah.
So for like the 7 seg, how do we make it so that like it doesn't just show 0 and then 1, like the numbers?
That's okay. I mean, if you show 001, I'm not gonna be upset about that.
Oh, okay.
What you could do is you could have some logic that if the first digit if the leading 0, if the first digit of your answer is a 0, just make it blank. But of course you'd want to make sure, I mean, this is basically what you're trying to implement. You can imagine a case statement or an if statement that does something like this, right? Let's say your answer is 100. Well, you should just show 100. But if your answer is 001, you should just do a 1. So you don't want to, it's not like all zeros are bad. It's just the zeros at the beginning.
Mm-hmm.
If you have 025, you want it to be 25. If you have 250, you obviously want it to be 250. So you could say like, let's say these are your digits. And I'm just coming up with this on the fly, I don't know. Let's say this is digit, let's say you got the 4 digits here, right? And you could say this is digit 3210. So if digit, these would actually be, hold on. Really, these would be, 3 down to 0, 7 down to 4, 11 down to 8, 9, 10. Wait, 8, 9, 10, 11. That would be 12. And then this would be 15, 14, 13. Oh, no, that'd be 12. Yeah, no, I had that right. Is this legible for you guys? Hold on, let me draw it a little bit different. So 15, 14, 13, 12. So this would be one digit. Then you have 11, 10, 9, 8. This would be another digit. 7, 6, 5, 4. That's another digit. 3, 2, 1, 0. That's another digit. So these would be your 4 digits. Mm-hmm. So you can say if digit 15, I'm going to just draw it a little abbreviated here rather than down to, 15 down to 12 is equal to 0, then you could have something here that says, maybe you have a signal that says blank 3 is equal to 1. Okay? Or we could have a signal, basically, okay, you have a signal blank that is a 3 down to 0, and it just says, should that digit be blanked out or not? All right. If that digit is equal to 0, then blank is equal to 1, 0, 0, 0. Does that make sense? So this is just a signal that you're later going to use to just like disable that number. Mm-hmm. Just an number. Else if digit 15 to 12 is equal to 0 and digit 11 down to, we'll just do 11 down to 8 is equal to 0, then blank 1, 1, 0, 0. So this is saying, is this, are you just have 1 0? Like, for example, this number. This one is saying, all right, do you have 2 zeros? And then else if digit 15 is equal, that down to 0 is 0, and digit 11 to 8 is equal to 0, and digit 7 down to 4 is equal to 0, then blank 1, 1, 1, 0. So this would be like if you had the number 0, 0, 0, 1. Mm-hmm. All right. Else, you're going to blank nothing because you still want to show a 0. Mm-hmm. And you want to show like a 1 or a 7 or whatever, right? Mm-hmm. So you could have this is basically leading 0 detector. Not really detector, but leading 0.
Yeah. And so would that be in like the top component, or would that just be like its own component?
You could just throw it somewhere in the top, right? And then you would have something like and I'd pretty soon have to go to the next office hours. But then you could have something like, then you'd use this signal somewhere to tell it to just like not, you'd turn the anode off or something, you know what I mean? So does that kind of thing make sense? That's how you'd get rid of a leading 0.
Yeah, makes sense.
So jot that down, take a screenshot, whatever you like.
Yeah, I got it.
I think you get that. And then, this is just like, I'm just kind of thinking out loud for these states. Might not exactly be these states, but just, kind of think about it, draw it out. And it's all just very intuitive. The states are just whatever makes sense, really.
Yeah.
And just think about it like in terms of that, and you could make something that you could, I want to have it as it'd be, whatever you can get done. Obviously, it's a final project for a class. You only have a couple weeks to work on it, but it'd be real neat if you could do 10 plus 7 enter, and then it just shows 17. If you got to do 10 plus 0, 7 enter, that's okay too. And you can always fall back on using switches and stuff, but that's a good calculator if it works like a normal pocket calculator that the average Joe or Jane could pick up and use.
Okay.
So, Cool. Okay. All right. I apologize. I got to go to the next office hours,
That's-
but if anything else comes up,
Yeah, thanks.
I still have some times available. So,
Totally fine. Thank you very much.
Thank you. Appreciate
Have
it.
a
Yeah.
good night.
all right. Thanks, you too. Bye.
Bye.